Okay, so yes, a function is a special kind of relation where each input has exactly one output. We talked about how to evaluate functions at certain values by plugging in those values for x. Then we talked about domain and range of certain functions. And then we talked about how to find the domain. So when we find the domain of an equation, we assume the domain is all real numbers. But there are two problems that can arise. Those problems are, number one, what can we not do? Divide by zero. Number two,
have a negative under a square root.
take the square root of a negative number. So the domain is all real numbers unless one of those two things occurs. Now, today what we're going to be doing is we're going to be finding domains and ranges of some more complicated things. So finding the domain is just as easy as what we've already worked on, but finding the range can be more difficult, especially if you do not know what the graph looks like. So our first example tells us to find the domain and range of a given function. It says use a graphing utility to find the domain and range of the function f of x equals the square root of 9 minus x squared. So we could find the domain on our own. We don't need a graphing utility. But the range would be more difficult without a graphing utility. So when I find domain, I look for those two problems that could occur. Could I divide by zero here? No. Could I take the square root of a negative? I could, right? Because there's a square root in this problem. So how do I make sure I do not take the square root of a negative? I take what's underneath the square root and I say it can't be negative. It must be greater than or equal to 0. So I could say 9 minus x squared must be greater than or equal to 0. I could add x squared to both sides. So that's going to tell me 9 is greater than or equal to x squared. And so look at this. I get x squared is less than or equal to 9. Well, now how do I get rid of a square? I have to take a square root. So that would be x plus or minus is less than or equal to plus or minus 3. Well, that's just confusing. How could x be less than or equal 3, but also less than or equal to negative 3? So So looking at this graph, what would we say the domain is? So the domain is the list of all possible x values. So I'm going to pull my graph up to make sure you all see the same thing I'm seeing. It should look like this. Okay, so when I'm looking for my domain, that's a list of all possible x values. So I'm starting over here on the left. What is the lowest x value the graph takes on?
2.8.
Okay, it's right here. Right? And again, my graph is not perfect. These graphing utilities are not perfect. It actually should be right at -3. And -3 is included in my domain. And remember, we had that weird answer that had something about plus or minus -3. Right? So we know that this 3's should be involved somehow. And because it was less than or equal to, we know that it's included at -3. So I put the bracket around -3. I told you I get those backwards all the time. Get used to it. Okay, now what is the highest x value my graph takes on? It is +3. That is correct. And it would also be included. So we could say the domain is from -3 to +3. Now the next thing we're going to look at is the range. So the range is the list of possible y values. So instead of a capital D, we're going to put a capital R. Now what is the lowest possible y value this graph takes on? It is, okay, so we can't tell exactly what it is, but we know it happens at 3, right? Whatever the lowest value is, it's happening at 3. So if you're second guessing yourself, plug in 3 here. What is 3 squared? 9. 9 minus 9 is 0. The square root of 0 is 0. So the lowest value that this graph takes on is 0. I know it doesn't look like it gets quite to 0 because these graphing calculators are not perfect. But it is. It's right at 0 is the lowest value. So the lowest y value, I'm going to put 0 included. And now what is the highest y value? 3. And it happens when x is 0, right? The y value is 3. Again, think what happens when you plug in 0 here. 0 squared is 0. 9 minus 0 is 0. Square root of 9 is 3. So at 0, we're having the highest possible value, which is at 3. Okay, so what is our domain? And those should both be included. -2 up to 2. Then the range is from 0 to 2. Both of those are included. Any questions? 100 feet per second at an angle of 45 degrees. The path of the baseball is given by f of x equals -0.0032 x squared plus x plus 3, where f of x is the height of the baseball and x is the horizontal distance from home plate. Will the baseball clear a 10-foot fence that is located 300 feet from home plate? Great question. Okay, so what we're going to do is we're going to use this graph to help us determine whether or not it will cross. So I'm going to go to y equals. I'm going to clear out my first equation. I'm going to enter in that equation that's given to me up here. So I'm going -0.032 x squared plus x plus 3. Everybody good here? Now when I click graph, what's that graph going to look like? Well, you see it's still going to be on the same path that I had before. And remember, this is the trajectory of a baseball. That's what we're looking at. So when x is 0, that's where the ball starts at home plate after he makes contact. Okay, so I don't care about any x's that are less than 0. Now we're wanting to look at how high the ball is at what distance? At 300 feet away. So if my x's represent the distance from home, and y represents the height, then I need to go at least 300 feet away to look at what's happening. So I'm going to go to window. Again, I don't care what happens less than 0 as my x-min. So I'm going to put my x-min in at 0. That's the ball at home plate. Now I've got to get my max to be at least 300. So I'm going to go with 350. Okay, just to make sure I can see it. Now again, if we're looking at trajectory of a baseball, so once it gets to a y value of 0, it's on the ground. Okay, so I don't need a y value that's less than 0. And to see how high the baseball goes, I mean, I can get a guess. How high y'all think a baseball goes? We got baseball players. How high you hit a baseball? How many feet?
450.
How many feet high? Not long. The x is the distance.
50.
Does it go 450 feet in the air, you think? Okay, well, let's put in 450 for the y max. Okay? So then we're going to hit graph. Well, you can barely even see that.
Wait, what'd you say the
Y min 0. Y max is 350. I don't know what the Y min is.
What's the one?
Say that's 20 feet.
What did I say the y minimum was? 0, because that's the ground level. Right?
And the maximum was 350.
The x max, we put in 350 because we're wanting to look what happens at 300.
That was it.
This is what my graph looked like. So see, I way overestimated how high the ball went. Right? It's very low compared to that. So I'm going to go in and change. So I'm going to go window. I'm going to change my y max to 200 feet. Then graph it again. I can see more what's going on that way.
Whoa, what was the X and Y and all that? Sorry, I was trying to clear my graph from the last program.
It's not letting it graph.
Okay, not with my dimensions it doesn't. If you change the scale, you might can see what's happening. Right there's what it looks like with my scale. I've got 0 to 100 on X, 0 to 20 on Y.
0 to 20.
And this is what it should look like.
That's what
0 to 80.
No.
I did 0 to 100. You can do 0 to 80, that's not a problem. But if you want it to look just like mine, put 0 to 100. So you can see if it looks like mine. So, now, I care about 60 feet away. So I'm clicking trace, and I'm going to where my X is 60. So I am right at about 9.5 feet at 60. If the first baseman can reach 8 feet, can they reach the ball without jumping?
Nope.
No. This is a very big equation that is used in calculus. Boy, my brain would not compute. It kept wanting to say physics, and I had to dig real deep to get to calculus. It's a shame, because we are in pre-calculus, and I couldn't remember calculus. So, the difference quotient is used in calculus, especially when you start defining what a limit is and finding a derivative. Do you know what either one of those things are? No. Are you going to know what a limit is by the end of this year? Yes. A derivative? Maybe, because I can't keep it away from you because I just like telling you how much I know. So, does it matter right now? All you need to know is look at this. This is called the difference quotient. One of the basic definitions in calculus, oh, right there's the word, employs the ratio f of x plus h minus f of x all over h, as long as h does not equal 0. So why do we have this in here?
So we remember.
Because you can't divide by 0. H can't be 0, or you divide by 0. And you give as many answers as Lauren, but you're not close on any of them. She used to be all over it. So anyway, this ratio is called a difference quotient, as illustrated in example 10. So we're going to look at example 10 next. Okay, so we've got a function, f of x. This is my function. F of x is x squared minus 4x plus 7. Now I want to find what I get when I plug that into the difference quotient, which is f of x plus h minus f of x all over h. Okay. Prepare to be amazed. So the first thing we need to find is f of x plus h. So how do I find f of x plus h? Everywhere there used to be an x, I'm now plugging in x plus h, just like we did before. Right? So let's do that. So f of x plus h is going to be equal to x plus h squared minus 4 times x plus h plus 7. Any questions so far about what I've done? I plugged in x plus h where x used to be. So this, in red, is the red part of my formula. Now, the next thing I must do, I must subtract f of x. So I'm going to write down what f of x is in blue. So what is f of x?
X plus h.
No. X squared minus 4x plus 7. It literally tells me what f of x is right here. I just copy it. That was pretty funny. So next, the only other part of my equation is the h. Well, guess what I'm going to put for h? I'm going to literally put h. Okay? So now I'm going to take all of those pieces and put it together in the distance formula. So this is what This is what the difference formula will look like. It's going to look like x plus h squared minus 4 times x plus h plus 7. Then there's a built-in minus. So I'm going to subtract all of f of x. So minus x squared minus 4x plus 7. And again, I'm subtracting all of that. And that's going to be over h.
Why is this necessary to live?
Because it teaches you how to take a derivative.
That makes no sense to me.
Let me rephrase the question. When outside of math class are we going to ever use that?
When do you use anything in math outside of math class?
Don't ever go here with that.
This is what I hope happens. I hope every one of y'all's phones and computers just crash. But I hope it's like 60 years from now and everybody that knows how to do math is dead. Okay? Then y'all got to rebuild all that knowing the math that y'all think you never need. Good luck. Good luck.
I could build computers.
I could.
Not without math, you can't.
I've done it before. I could do
Okay.
it.
And that's a little extreme. I don't hope that, maybe in 60 years I won't be dead, but I'll be 89, I probably will be. So. Okay. Yeah. Now I've got to simplify this. That's just plugging in. That's all I've done so far. I took a lot of time to plug in. Is everybody good with me plugging in? Everybody sees where that comes from?
Yes.
Okay. Because I've not done any of the fun part yet. I've just literally plugged in. That's all I've done. Now I got to do the math. Okay, simplifying. So if I have x plus h squared, I can rewrite that as x plus h times x plus h. Then I'm going to distribute here. So that's negative 4x minus 4h. Then I have plus 7. And now I have to distribute this negative 1 to everything in the blue. So that becomes a negative x squared, a positive 4x, and a negative 7. All over h. I am. I'm waiting. Are we ready? I know, you're big note takers. I used to never take these math notes. I would watch the teacher do it, and then I would just try to do it on my own.
That's me. I literally never take
That's
notes.
the word we call.
I don't even copy.
That's fine, do
it
whatever
down.
you want, I'm not mad at you. Are you ready? Now, I have two parentheses in front. So what I need to do to those two parentheses? No, don't say that word. God, that's a bad word. That's a banned word in this class. Yeah, don't say that.
What's fold?
Yes, we need to distribute those two parentheses. Okay? So we distribute them. If you fold something, I think you're going to put it in the fridge and save it as for leftovers. All right? It's not what we're doing. FOIL is a method to help you remember how to distribute. So FOIL is not a verb. You can't say you FOIL it. That's not. All right, we're going to sound intelligent in here. So you're going to distribute. X times x is x squared. XH and XH, that gives me 2XHs. H and H is H squared. Now I'm going to bring everything else down. Minus 4x minus 4h plus 7 minus x squared plus 4x minus 7. All over h. Huh? Yep, I sure did. Thanks. Appreciate you, Ian. No, that's a bad line.
Over 8.
Yep, all over h.
Equations of cash, what are you getting to?
Now I need to, can I go?
Yes.
I need to combine like terms in the numerator. So I have an x squared. Do I have anything like x squared? Negative x squared. Those cancel. Next, I'm looking at 2xh. Do I have anything like 2xh? I do not. So I'm going to bring down 2xh. Next, I'm looking at h squared. Do I have anything like h squared? No. So plus h squared. Next, I'm looking at negative 4x. Do I have anything like negative 4x? Positive 4x. Cancels. Next, I'm going to look at negative 4h. Do I have anything like negative 4h? No. Next, I'm going to look at 7. Do I have anything like 7? Negative 7. If you do this correctly, every term you have left in the numerator should have an h. If you have anything without an h, you've messed up. See how all three terms in the numerator have an h? Now, why do I say that you're going to always have an h? Because there's an h in the denominator. Now, in the numerator, I can GCF an h out of all those terms. So this becomes h times 2x plus h minus 4. All over h. H's cancel. So that leaves me with 2x plus h minus 4. Final answer.